Okay, I wanted to touch briefly on something that I've actually been forgetting about, most of the videos I made, but I always run these types of tests. And this is a circuit from a previous video. It's that 3 amp 0 to 30 volt or 2 to 30 volt supply or whatnot, based on a 723 regulator. Yeah, it's basically this circuit here, with this as its circuit board and so forth. But, basically works and, works fairly well. But one of the things I hadn't been touching on, which I, kind of mean to, but I keep forgetting, is, actually hooking these up. I got it at 33 volts right now, and, powering with 37 volts in, so 20 milliamps. But, I wanted to show you the scope, the oscilloscope. You should always, and the reason I test a lot of these power supplies using a lab supply as my basis, it's one of the first tests I always run, and the reason is so you can actually isolate the device itself and see what kind of noise the power supply itself actually generates. And right here it's basically channel 2, so it's like 390 to maybe 600 millivolts, which is actually quite noisy, based on where it's at. Now let me hook a load on. It's kind of warmed up now, and it's about the same when I actually got a load on it. It's pulling I've got the current limit set, down quite a ways. Let me turn it up just a little bit. Oops, I'm going the wrong direction. Damn it. Oh God, I hate these things. Okay. That was about 49 milliamps or so. And, you can see the short-circuited noise, we're at 4.6 volts, but it's, it's about somewhere around, half a volt. So some of this is probably coming from local noise, too, because I get that on about everything over here. But, you can see that, there's certainly some noise on it. Let me disconnect it from the load, but yeah, it's got a fair amount of noise, and this is with no output capacitor filtering or anything like that, which would, probably be a good idea to put, maybe 10 microfarad or more, of output capacitance. More is necessary, to get that noise, down. But, these, regulators will have variable, noise issues, and especially some of them, you do some of those like op-amp based regulators, with a pass transistor and stuff like that. Those can sometimes be really noisy. So, it's something, that you got to be aware of. And like I said, it's always instructive, to put these things on a, on a laboratory supply, which is basically pre-filtered. Now this is, supply itself is going to generate its own frequency noise. It's a switch mode supply, so some of this can be coming from that. It can be more instructed to put it on a linear supply, which if I was really serious, I would, do that for sure, because that helps minimize, variables like that. I'm adjusting the voltage down, as we speak, just to get a clearer look at it. Adjust it down quite a ways. So let's see, get it down to like 8 volts. Let's set it at 8 volts, and well, let me set it at 5 volts. That'll be even better. Okay. Alright. So there you go. Alright, like I said, I got this signal set up. Let me 2 volts per division, 1 volt per division. So, you know, we're getting a better look at some of the noise chatter there. And it's like I said, it's about a half a volt, you know, of sporadic noise. But again, you could probably put an output capacitor on that to smooth that out, because, you know, as you see, you know, in the design, you know, there is, well, I guess I got a 100 microfarad output capacitor on it already. So, you know, that should offer some filtering, but it might need a larger one. But again, putting it on a linear supply might be a good idea, because again, you got a lot of high frequency noise coming from some of these switch mode supplies. So I can't rule out that having a contribution. I think that's a linear supply I could try to put it on. But, you know, anyway, the point is, it's always good to test power supplies out with a lab supply first, just so you can see what kind of noise the supply itself generates, you know, irrespective of your source. So, but again, you know, you can put this on a linear supply. Let me do that real quick, just to see if there's a difference, because I'm not sure. I've never done that with this circuit. Alright, so I went ahead and hooked it up to my linear supply over there, and you can see that, you know, it's about 230 millivolts of noise, but there's still some noise on it. And like I said, it's hard to say what's coming from where. So let me take my other oscilloscope probe, bear with me. Okay, now taking my other oscilloscope probe and put it on, you know, the input from the power supply, and you can see that it's showing, you know, it's a yellow trace, you know, up there at the top. So, you know, we're still at 5 volts, you know, where I set the power supply, and I got that set to 1 volt per division versus 5 volts per division. Shit, that's hard to see, isn't it? Still hard to see. Like, this camera is not very glowy thing friendly. Yeah, it's 5 volt per division versus 1 volt per division. So the yellow line up there is your power supply input, and that's our output. So, which I got set at 5 volts. But you can see the noise, you know, on the input, you know, is that level versus that level. It's a little less noisy coming out of our power supply. So that's coming from the linear supply, because I'm using this supply right now, and I got it set to, you know, 32 volts. But let me go ahead and disconnect the, well, let me see. I guess if I do that, that'll get me trouble. Let me go ahead and disconnect the circuit manually here. You know, so let's see what the input power looks like with no load connected to it, just to see if it improves. Well, see, our output has dropped to nothing, and it's still got a lot of noise on it, despite the fact it's got no output. So, but our input still got the same, roughly the same noise level it had. So, I mean, a lot of that you got to attribute to the power supply itself, or all this line, you know, because again, there's something around here, you know, this equipment generates a lot of noise. I mean, you know, it's really bad on the analog discovery. But let me go ahead and connect it back up again. So again, a lot of that, you know, again, it looks bigger on the blue trace because I've got it, you know, it's 5 volts, okay, so I've got it to, you know, 1 volt per division or so, but the markers down here, so it's 1, 2, 3, 4, 5, because I had to move everything down there. I could have put it to AC coupling, but still, it's reassuring to put it in DC, so you're sure to see everything. But at any rate, you know, but the point is that, you know, it's good to test these supplies this way first when you first build them, just to see how noisy. Man, I have had, you know, some power supplies. In fact, here, let me pause the video, find an example. Yeah, this is a good example, like, you know, this out of Hazen again. Some power supplies like this, you know, or this one in particular. I was shocked this thing even worked. I mean, if you look at how they have it referenced and how they have this wired up, you're like, holy shit, I can't believe this thing functions. It does work, but boy, it's got some limitations. But it will put out some noise. But the upper, it's supposed to be a dual tracking power supply. But man, there's a lot of flaws with this. I actually blew it out by trying to charge a capacitor across both output terminals. Otherwise, it was well behaved before that. But given how they have this set up, I'm surprised it worked as well as it did. But a lot of these little linear power supplies you see these all over the internet. The bulk pass transistors. Usually they start with something like this, and then they start introducing op amps. Sometimes those op amps, can really start to generate some oscillations. And I had problems like that with several of the supplies I built. That you kind of see around here, but yeah, they can actually generate quite a damn bit of noise sometimes. I mean, it can really make you pull your hair out. Just building even simple supplies like that can be really noisy. So it's always good to test your supplies this way first before you actually hook it up to like a normal filtered transformer, like you would normally have as an input, to the power supply, the bridge rectifier, large input capacitor. And like I said, you can, if you look at Elliott Sound Products, they got a good power supply design article. So that he also talks about some other options like pi filters and things like that that can give you really smooth input. Could really, really, at least according to the Fallstat simulations I did, they can really, knock a lot of that, that ripple down. So if you need a really quiet supply, you might consider some of those options. They have caveats, but like I said, let me go look at some of these Elliott Sound Products articles. These are all articles of his that I've bookmarked. I read through most of it. He's got some, amplifier basics and a lot of stuff. Again, most of it's oriented towards audio, but, he's not strictly beholden to that. Sometimes, he's got whole articles on power supplies and things like that that are worthwhile to read through if you're trying to do things like this. But again, I'm not testing any of these that way because I just don't have a power, just a filtered power supply handy over here. The voltage regulators article. Here's one of his articles. See, this is his site right here. So, this is one of a 3-part series, I think. So, but again, somewhere in here, in this series of articles, he talks, if I'm not mistaken, he talks about, pi filters and things like that. I think it was, let me look at it. I think I marked that specifically because I was curious about pi filters. Yeah, right here. This is in a capacitance multiplier, but he talks about them elsewhere too. It's not just in here. So this might not have been the best reference, but right here is a pi filter he built, to get rid of a lot of that ripple, out of it. And but as he points out, there are caveats, but there's a lot of ways, if you really need to get minimal noise, you can look into things like that, which he's, talks about various options for doing that. It's a good series of articles. I mean, if you really want to brush up on electronics or learn electronics, if you already word of caution, you should already know something about electronics before reading those articles. So he does have some introductory articles, but they're going to be still a little out of your wheelhouse until you know a little more from other places. But at any rate, normally I would test things like that, and with a transformer and stuff. I just don't have one handy. I mean, I could build one up. I got a whole box full of transformers and stuff over there, and but it's just I don't have one lying around. I do have some I built up. You see that device over there above the high voltage supply with the red faces. That thing will do like 20 kilovolts, and it's based on a neon sign transformer. But anyway, sitting on top of that, that actually is a a transformer, those little glowing displays there, those are actually hooked to a stereo transformer that had two 70-volt, winding sets out of it. So, I got one of them as plus or minus, unfiltered AC, so I could hook things up to them that are like dual supplies and so forth, and the other is, I put some basic filtering on it, so I could hook something like this up to it, even up to 70 volts, and it's what I call a variac accessory. It's I got a variac over there on the bench that you can't see, that's yeah, hidden behind that stupid thing. Well, you can see it. It's right by that little laptop thing. Laptop thing is right there, and it's right there. But at any rate, that's a variable supply, but also got a variac over there. It's a more general purpose variac, as you can barely see. But at any rate, you usually hook that up to either that high voltage supply or that, because that high voltage supply is variable because it's a neon sign transformer basically in there with a multiplier and some things like that. But it's a variac accessory, so it's variable over a considerable range of voltage. With like 20 milliamps of current capacity in it. It's a NST. But then same too applies to that that stereo transformer I got in there. That's limited about an amp or so, though. That's the thing, kind of sucks. But it's 70 volts, so split split supply. So, and there's two of them in there. So that's good for doing things like that. But I don't want to have to move everything over there to the bench, and I'm not that interested. I just wanted to see if these circuits work. I really should have built these or tested them a couple of years ago before I built all those power supplies, because that's what the point was. But I got gung-ho about it and just went ahead and built the supplies anyway without testing these. So I'm not that interested in really testing these, for its ripple rejection and all that stuff, but you can do that yourself. But anyway, it's just always a good, because if we're going to actually develop around one of these boards, I would be testing this that way. So, putting it through an filtered, output, transformer, so that you can kind of see how it performs in that way too. But you want to do tests like that yourself, but it's also always a good idea to start with tests like this. So it'll give you a good idea before you actually start dealing with the complexities of hooking it up with AC ripple and all the line noise that may come in on it and everything. To just look at this power supply itself to see if it performs well under a more controlled condition before you hook it up that way. Then you'll have a better idea what you're in for. So anyway, I just wanted to kind of point some of those things out, while I, had the chance before it slips my mind again. So, anyway, I'll, that pretty much wraps it up for this video, so cheers.